Hi friends and welcome back again. Today we're going to solve together a question on coordinate geometry. The question reads, triangle ABC has vertices at point A, point B and point C. Find its area and show that it is an isosceles triangle. Okay, so how do we solve this very problem? As long as there are three vertices or 3 points, then this is a formula that we are going to use. We say the area, okay, this is the formula to use whenever the triangle has 3 vertices, or let's say, yeah, has 3 vertices. So you say the area equals 1 over 2, and then you put the absolute value sign, which is the vertical bar, and then inside you write x1, x2, x sub 3, then x sub 1 again. And again, you write under y sub 1, y sub 2, y sub 3, and then y sub 1 again. Then you can close the vertical bar. Okay, so for a lot of students, this formula is very challenging that they don't know how to use it. Okay, so see what you're going to do. To be able to simplify this, here is what you have to do. So you say the area is giving us 1 over 2. Then you also place a vertical bar right here and you open a bracket. Then just cross them this way, x1, y2, x2, y3, then x3, y1. Let's write them down here. x1, y2 plus, again we have x2, y3 or y sub 3, and lastly plus x sub 3, y sub 1. Then you can close it and you say minus. You open another bracket. Right here we have y1 x2, okay, just like crisscrossing. Again, y2 x sub 3, and then y3 x sub 1. So let's do that. We have y1 x sub 2 plus y2 x sub 3, and then plus y3, we have x sub 1. Okay, then you close it, and you can also place the absolute value bar here. All right, now let's go back and define our given parameters. So we're given 3 vertices. The first one was A, and for our A, we had negative 6, comma 3. So here we have negative 6, comma 3. And then for our B, we had 3, comma 5, 3, comma 5. And for our C, we had 1, comma negative 4. Let me check if that is correct. 1, comma negative 4. All right, that's okay. That's correct. Now let's define them. Here is how you are going to do them on your paper. So this one is our first one. Okay, so it can be written as 0.1. These are 0.2. And these are 0.3. And then you say, here you have x1. Okay, the first value here inside this bracket is the x coordinate. So you can say x sub 1, while the second one is your y coordinate. So you now have y sub 1. So for your first point, you can see we've defined it to be x sub 1, which is the x component or the x coordinate, and then y coordinate. And for the second one, we can say x sub 2 and then y sub 2. For the next one, we have x sub 3 and then y sub 3. Defining them this way would make it easier for you to use the formula in order not to make silly mistakes. So we write the area is giving us 1 over 2. Then here we have our vertical bar, which is the absolute value. This means that the answer must always come out, the area must always come out as a positive value and never as a negative. Okay, so now what is our x1? We're basically going to multiply them together. So what's our x1? Our x1 is negative 6. So we say negative 6, then multiplied by our y2 is 5. So we have negative 6 times 5. Again, we have plus, we have our x2. Our x sub 2 is 3. So we say 3, then multiplied by y3. Our y3 is negative 4. So you have 3 multiplied by negative 4. Again, you have plus, our x3 is 1. So you say 1 multiplied by our y1. We ought to be very careful when using this very formula. Our y1 is 3. So this now gives us 1 multiplied by 3. And then we can now close the bracket and put our negative sign, open another one. And then now next we have y1. Our y1 is 3. So we have 3 multiplied by x2 or x sub 2. X sub 2 is 3. Then plus, the next one is y2 or y sub 2, which is a 5. Then 5 multiplied by x sub 3, which is a 1. And then finally, we have plus y sub 3 is negative 4. So negative 4 multiplied by x sub 1, and x sub 1 is negative 6. Okay, so we can close our bracket and also put our absolute value sign. So let's simplify to arrive at the solution. So we said that the area is equal to 1 over 2 multiplied, okay, this is the absolute value, we place it there again. So negative 6 times 5 is negative 30, so we say negative 30. Again, 3 times negative 4 is negative 12, and then 1 times 3 is 3, so we say plus 3. All right, then we can now close this very bracket here, and then we have a negative. Let's evaluate this. 3 times 3 is 9. 5 times 1 is 5. And negative 4 times negative 6 will give us a positive 24. Again, the area equals 1 over 2. Then negative 30, negative 12 gives us negative 42. And negative 42, we have the plus 3 remaining. Then minus 9 plus 5 plus 24 gives us a 38. Again, we have the area equals 1/2. Negative 42 plus 3 is negative 39. The negative times the positive 38 gives us negative 38. Remember that the answer must always come out as a positive value. Then we have that the area equals 1 over 2. Then negative 39, negative 38 equals negative 77. So we have the absolute value of negative 77. And then the area equals 77 divided by 2 is 38.5. So the area is 38.5. So this is the area of the triangle. Okay, now we use this very formula because it has 3 vertices, so that's why we're using this very formula, and I hope you learn how to use it. So having found the area, you can say 38.5 units. Now the next thing that we're going to do is to prove that this is an isosceles triangle. So for part B, how do we prove that a triangle is an isosceles triangle? Well, if there are 2 sides that are of equal length, here we have, for example, a triangle, and then you have A, point B, and point C. If point AB, or let's say if distance AB equals distance AC, as long as 2 sides are equal, then we can say that this triangle is an isosceles triangle. And that is how to prove it. Okay, now how do we do this? We are simply going to use the distance formula to do this. Because with the distance formula, you can get the distance AB, you can get distance AC, and you can also get distance BC. When you get these three distances, then you can compare them. If you have at least two sides that are equal, then it means that a triangle is an isosceles triangle. Now let's copy the coordinates again. For point A, -6, -3, or -6, 3. So for A, we have -6, 3. For B, we have 3, 5. And then C, we have 1, -4. Let's cross-check for consistency. So we have 3, 5, 1, -4. Okay, now let's see how we can do this. So we are going to begin with distance AB. So we say distance AB to show that we want to find the distance between A and B. Now the distance formula is x2 or x sub 2 minus x sub 1 squared, then plus y sub 2 minus y sub 1 all squared. Okay, since we're using AB now, we can say that this is our x sub 1, y sub 1. And this is our x sub 2, y sub 2. We're doing AB first. So let's plug in our values. This is equal to the square root. Our x sub 2 is 3, so we say 3. Then minus our x sub 1 is -6. So this now gives us -6 all squared plus our y sub 2 is 5. Then minus our y sub 1 is 3 all squared. Let's simplify further. This equals the square root. So minus times minus gives us a plus, and that gives us 3 plus 6 all squared plus 5 minus 3 is a 2, so this is 2 squared. Again, we have distance AB equals 3 plus 6 is 9 squared plus 2 squared is, sorry, okay, yeah, that's correct. 3 plus 6 is 9 squared, and 2 squared is 4. Again, this is equal to 9 squared is 81, and then plus 4. So this leaves us with the square root of 81 plus 4 is 85. So root 85 units. So this means that the distance between A and B equals root 85 units. Okay, now we've done for AB. We now have to do for AC. So let's do for AC to see what we're going to find. So here we have our coordinates again. We have A to be -6, 3, and then B is 3, 5, then C is 1, -4. Let's check again for consistency. -6, 3, 3, 5, and 1, -4. Okay, so we've done AB and we got root 84. Let's now do AC. So we say distance AC equals the square root again. And now we say x2 minus x1 plus y2 minus y1. So distance AC equals, so we can take this one now to be our 1 and C to be our 2. So we can also define the coordinates again. Here we have x1, y1, we have our x2, y2. Okay, so let's plug in what we have and find the distance. Our x sub 2 is -4, 1 rather, not negative 4. See, that's the reason why it's very important to always list them this way so that you don't make any mistake. So this is our x2, okay? So our x2 is 1, and then minus our x1 is negative 1. So this is negative 6. Okay, then our squared, then plus, here we have our y2. Our y2 is negative 4 minus our y1 is 3. So this is negative 4, negative 3, all squared. Distance AC equals the square root. So let's simplify. Negative times negative is a plus. So we are left with 1 plus 6 all squared, then plus negative 4, negative 3 is negative 7. So we have negative 7 all squared. Then distance AC equals 1 plus 6 is 7. So we have 7 all squared, then plus negative 7 all squared. Right here we have distance AC to be equal to, so 7 squared is 49 plus 49, and then when you add the two of them, you get the square root of 98. So this implies that distance AC equals the square root of 98 units. Okay, now we found distance AB to be root 64 as we found originally. Okay, root 85, right? Okay, root 85. That was what we found. And then we found distance AC to be root 98. So let's go ahead and find distance BC. We define our given coordinates again. We have point A to be negative 6, 3, B to be 3, 5, and then C, we have 1, negative 4. Again, we now do distance BC. For distance BC, we also use the same distance formula, the square root, so we can now call this one our 1. So this is now our 1, the B is now our 1, and C is now our 2. So we say x1, y1, x2, y2. So the formula remains x2 minus x1 all squared plus y2 minus y1 all squared. So distance BC equals, let's plug in and start solving. Our x2 here is 1. So we have a 1, then minus our x1 in this case is 3. So we say this is 1 minus 3 all squared, then plus our y2 is negative 4. So we have negative 4, then minus our y1, which is 5. Okay, then distance BC equals 1 minus 3 is negative 2. So you have negative 2 all squared plus negative 4, negative 5 is negative 9 all squared. Distance BC equals negative 2 squared is a 4, and then negative 9 squared is 81. Distance BC equals 4 plus 81 is 85. So this means that distance BC equals the square root of 85. And then what does it mean? Remember that we got distance AC, okay, or distance AB rather, not AC. We got distance AB to be equal to the square root of 85. And we also got distance BC to be equal to the square root of 85. Since distance AB equals distance BC, so this implies that the triangle is isosceles. Okay? Okay, so this is the solution, and here is how to prove that a triangle is isosceles, and this is also how to calculate the area of the triangle. Thank you for watching this video, and see you in the next one.